Good morning or afternoon. It is Miss Figueroa and today is November 16th and we'll be doing factoring when a is greater than 1. So on Friday we started factoring polynomials, so factoring our quadratics. And so today we're doing factoring when a is greater than 1, which is that first coefficient. So remember our quadratics are ax squared plus bx plus c. So a is greater than 1, meaning it looks like we have a coefficient. If a is 1, it looks like we don't have one. So an example of a equals 1 would be like x squared plus 4x plus 6. Something like that, where we don't necessarily see the coefficient in the front. We know that it is a 1. We have 1x squared. So today we're doing, obviously, if you look at the problems, there are numbers in the front of them. So the way that I like to do factoring when a is greater than 1 is using grouping. So we factored by grouping last week when we had 4 terms. So I'm going to do this by grouping. I know some people like to work using the box method. So if you like the box method, then there are plenty of tutorial videos on YouTube, maybe Khan Academy or Patrick JMT, I think his name is, where they will go through the box method, but I prefer to do grouping. So with grouping, we have several steps. The first one is to multiply those two terms. So 2x squared and 5 gives me 10x squared. So 10x squared is now my goal. I want to find two numbers that multiply to 10 but add to 7. So the same way that we were factoring when a equals 1, where we're solving that kind of riddle, we're going to do the same thing, but now with our new middle term, well, our new initial term, which is 10x squared. So I need to find two numbers that multiply to 10x squared, but add to 7x. So the more we do these, I'm going to drop the x squared and the x, and we're only going to focus on the numbers. But I do want you to see that we are going to be using the x's because they're going to come back when we start writing out the terms. So multiply to 10 but add to 7 looks like it would be, let's write out our factors of 10. So this is what you would do if you didn't know. You would find out what your factors of 10 are. So like 1 times 10 and then add across. 1 plus 10 is 11. So that's not going to add to 7. 2 and 5. 2 plus 5 gives me 7. Perfect. So we are going to use 2 and 5, which is what we had initially. So 2x squared plus 2x. So drop the first one and then write out what your new term is, which is 2x. Then the new term again, and then drop that last term. So we separated 10x squared into 2x and 5x. So now we're going to factor by grouping. So you see that I have 4 terms, like when we factored by grouping, and then I'm going to split them apart and find the GCF on both sides, which is 2x over here, and I would have x plus 1 left over. Over here, there's a 5 that I can take out of both. I would still need an x plus 1. Just like in factoring by grouping, these have to be the same. If they are not the same, you missed a step somewhere, you made a mistake. So then I'm going to write out my factors by combining the 2 outside, 2x and a positive 5, and the one that is duplicated, so the one that I have 2 times, the one that is highlighted, I only write once. And so those are my factors that would give me 2x squared plus 7x plus 5. Now, if you needed to check Is my answer correct? You would multiply that back out. So 2x plus 5 times x plus 1. We're going to FOIL this out. So it's 2x times x, and then 2x times 1. 2x times x is 2x squared. 2x times 1 is 2x. We gotta do the bottom. 5 times x is 5x. 5 times 1 is 5. And then we'll combine our like terms. I see 2x and 5x. So I get 2x squared plus 7x plus 5. Is that my initial problem? Yes. So that means my factors are correct, and I did this problem correctly. So now we're going to move to example 2. We have 3x squared minus 14x plus 8. So again, the first thing I want to do is multiply 3x squared and 8, which gives me 24x squared. So I want to multiply to 24x squared, but add to negative 14x, that middle term. So if I don't know, I'll write out my factors of 24 and see which one will give me negative 14. So we see there's going to be something with negatives. I need to add to a negative 14, but multiply to a positive. So that means both of my terms will have to be negative. So let's do negative 1 times negative 24. If I add those together, will I get negative 14? No. Negative 2 times negative 12. If I add those together, will I get negative 14? Yes. So those are the factors that I'm using of 24. Bring down the first, 3x squared minus 2x. You can write these in either order, so if the 12 was going to go first, that's fine. And then I have minus 12x, bring down the 8, so plus 8. This is my new problem that I'm going to be factoring. 3x squared minus 2x minus 12x plus 8. I expanded the problem to 4 terms. Split it down the middle, find the GCF on both sides. So the greatest thing that I can divide 3x squared and negative 2x by, there's no common factor on 3 and 2, but they both have an x. So I'll take out the smallest power of x, which is just x. In order to get x to 3x squared, I have to multiply with 3x still. And then in order to get x to negative 2x, I need minus 2. Now on the other side, negative 12x plus 8, negative 12 and 8 have a 4 in common. If it's negative, drop the negative, always. So negative 4 will be my common factor. Negative 4 to negative 12x, I need to multiply by 3x. Negative 4 to positive 8, I need to multiply by a negative 2. Make sure these are the same. The 2 on the outside come together, and then the inside only once. Then we'll do these practice problems as well. 2x squared plus 7x plus 6. So it looks just like the example, but has a 6 on the end. So we'll multiply 2x squared and 6, which gives me 12x squared. So let's do my factors of 12. I need them to add to 7. 1 and 12, nope. 2 and 6, 2 plus 6 is 8, no. 3 and 4, 3 plus 4 is 7. So 3 and 4 are the two factors of 12 that I'm using. Bring down this 2x squared. Write either the 3 or the 4, it doesn't matter. We'll do the 3. Make sure it gets an x. the other factor, which is 4x, bring down the 6. Split it in half, and then find the GCF on both sides. So here, 2x squared plus 3x, I only have an x in common. I will still need to multiply by 2x into 3. On the other side, 4x plus 6, I have a 2 in common. We steal the sign here, so it's a positive 2. And then it would still need a 2x and a 3. If you're struggling with finding out what it still needs, like what's going to go in the parentheses, if I have 2x squared and my common factor was an x, do the division. I have 3x, my common factor was an x, sorry. So that's a 3 left, that's a 2x left. Same thing on the other side. I have 4x, my common factor was a 2. That leaves me 2x. I have 6, my common factor was a 2. That leaves me 3. Check that these are the same. They are, so I've done this correctly. Bring down the 2 on the outside together, x plus 2, and then 2x plus 3. So the reason I like using grouping to factor these where a is greater than 1 is because we do have that checkpoint. Are my parentheses the same? In other methods, we don't have that checkpoint, so you would have to go back and use the whole process to check, is my answer correct? Most likely when you're using grouping, if you end up with the same parentheses, I mean, if you jump ahead and say, well, they have to be the same, so I'm just going to write it twice, then it's possible that you're going to make a mistake. But if you're going through every single step slowly and carefully, then you are going to have that checkpoint, and then you can say, well, my answer is going to be correct because I got the same parentheses. So we'll do the same thing on practice 2. We're going to multiply first and last term. 4x squared plus 5 is 20x squared. So I need to multiply to 20, but add to negative 9. So remember, we add to the middle term. Add to negative 9, multiply to positive 20. I'm going to be using negative numbers. So negative 1 times negative 20. Do those add to negative 9? No. Negative 2 times negative 10. Those add to negative 12, so no. Can't use 3. 4. Negative 4, negative 5. Those do add to negative 9. So negative 4 and negative 5 are going to be the factors that I'm using to break apart that 20x squared. Bring down the first one, 4x squared minus 4x, write one of my factors. Write the other factor, negative 5x, bring down that last term. Cut it in half, find the GCF on both sides. 4x squared minus 4x. What's in common is a 4x. I still need an x. I still need a negative 1. Bring down the negative. What's in common between 5x and 5 is 5. Remember, I took out a negative 5. So negative 5 to get to negative 5x, I need negative, oops, sorry, it's already negative. I need a positive x. Negative 5 to positive 5, I need a negative 1. Again, if you need to do the division off to the side, that's perfectly fine. I've been doing this for years and years and years, so it's easier for me to do it in my head, but there's no problem with having to do this little division off to the side if that helps you to get your answer correct. So I have these two parentheses, and they are the same. That's my checkpoint. So I'm going to go ahead and write my answer. Squish together those two outside pieces, so 4x minus 5. And then write the factor that is twice only once, x minus 1. Then on the next part, we have find the roots of the quadratic equation. So in Algebra 1, 2 years ago, we learned that roots has other names. It has x-intercept. It has solution. So if you see find the solution, it means the same thing as find the roots as find the x-intercepts. So we're going to find the roots of each quadratic equation by factoring. After Thanksgiving break, we'll learn a new way to find our roots that we briefly cover in Algebra 1, but for today, we're going to be using factoring. And this is something that you will use in your next math class if you do take math next year. So 2x squared plus 9x plus 4 equals 0. This is important. Always make sure before you start to factor that it equals 0. So it looks like on all these examples, oh, no, not on 2a, that you have equals 0, so you can just start factoring. If you have something like 2a, then you do need to start by moving things over so that way you have equals 0. So we have 2x squared plus 9x plus 4. It looks like the problems that we were doing before. Multiply first and last. 2x squared plus times 4, is 8x squared. I need two numbers that multiply to 8 but add to 9, which is 1 and 8. So 2x squared plus 1x plus 8x plus 4. So we are going to start dropping steps as I do these. So just if you need those extra steps, go back in and add them to your problem. So we split apart 8x squared, and we got 1x and 8x. And we'll cut this in half on the GCF on both sides. And 2x squared and 1x, the only thing in common is an x, so we'll still need a 2x and a 1. Then on the other side, 8x and 4, what's in common is a 2. Remember, we dropped that sign, so it's a positive 2. And then we'll still need a 4x and a 2. Uh-oh, these don't match. So that means there's something greater than I can pull out of 8x and 4. So remember, that's your checkpoint. That's how you know, am I doing this correctly? I know that I made a mistake because they didn't match. So what's in common between 8x and 4 is really a 4. So we're taking out the greatest thing. And that leaves me with a 2x plus 1. They are the same now. So I know that I can write out my factors, which is x plus 4 and 2x plus 1. So I rewrote 2x squared plus 9x plus 4 as x plus 4 times 2x plus 1, so it still equals 0. Now there's this thing called the zero product property, which means that I have two numbers, a times b, and they equal 0, then either a equals 0, or b equals 0, or both. Because we know anything times 0 is 0. So x plus 4 times 2x plus 1 equals 0. If this is my a and this is my b, then either a equals 0, b equals 0, or they both equal 0. So in order to find the roots, the solutions, we will set each of them equal to 0. So x plus 4 equals 0, and solve for x. I'm going to move that 4 over. I get x equals negative 4. 2x plus 1 equals 0. We'll subtract 1. We get 2x equals negative 1. Divide by 2. And x equals negative 1/2. So I have found the roots, the x-intercepts, the solutions. X equals negative 1/2 and x equals negative 4. Remember with our quadratics, the parabola, it can cross twice. It can cross once by just hitting, or it can be never. That's where we wouldn't be able to factor. We would have no solution. So just be aware of that. That's why we're finding two different ones, because we are crossing that x-axis twice. So then on number 1a, we have 2x squared minus x minus 3 equals 0 equals 0. So I can go ahead. First thing I'm going to do is multiply the first and the last term. 2x squared times negative 3 is negative 6x squared. And I need to add to a negative 1. So negative 1 is going to be negative 3 and positive 2. So 2x squared plus 2x minus 3x minus 3. Cut the problem in half, find the GCF on both sides. 2x, x plus 1, minus 3, we pull out that negative, and then x plus 1, they are the same. That's my checkpoint. So 2x minus 3 times x plus 1 equals 0. Using the zero product property, I'm going to find my roots. So 2x minus 3 equals 0. Add 3 to both sides. 2x equals 3. Divide by 2. X equals 3 over 2. And x plus 1 equals 0. Subtract 1. X equals negative 1. So then my zeros, my roots, my solutions, it's going to be x equals 3 over 2 or x equals negative 1. Then on number 2, we have 2x squared minus 8x minus 24 equals 0. So what I'm going to do is multiply first and last term. Oh, I see something. So whenever we have a GCF across the entire problem, we need to take that out first. 2, 8, 24 can all be divided by 2. So I'm going to take out a 2 first, divide each term by 2, so I get x squared minus 4x minus 10 equals 0. And then I will factor that middle part. So all of this in the middle, I'm going to factor. And this goes back to what we did on Friday, because a is 1. So we need to find two numbers that multiply to negative 10, but add to negative 4. Negative 10. We have negative 1 times negative 10. It's negative 11, so no. Negative 2 times negative 5. Negative 7, so no. Was no one going to tell me that I wrote negative 10 when it should be negative 2? So here, sorry, I said negative 2. I am struggling this morning. It feels like a Monday, but it is a Tuesday. So we have negative 12 on the inside there that we're going to be factoring. So we need two numbers that multiply to negative 12, but add to negative 4. So when we have to multiply to a negative and add to a negative, we have to be careful with our signs. So negative 1 times positive 12 is negative 12. So you see how we have to be very careful there? I already know what it is. So to get to negative 12, I'm going to use negative 6 and positive 2. So I have 2x minus 6, x plus 2 equals 0. So how I found those factors was by using the method that we used on Friday. So if you need to go back to that video, just go ahead and do that. So now we have our factors and they equal 0. And I'm going to use that zero product property to find what the zeros are. So can 2 equal 0? Absolutely not. So we're going to ignore that the 2 is in the front there. So we have x minus 6 is equal to 0, which means that x equals 6. We also have x plus 2 equals 0, which means x is negative 2. So my zeros, x equals negative 2 and positive 6. If you're struggling with this factoring concept, that is okay. Factoring is it is a difficult concept to grasp. It does take quite a lot of practice. So if you are looking at the screen and you are saying, absolutely not, there is no way ever, there is a way. It will happen and you will be fine. It is not as difficult as it seems the first couple of times that you do it. The main thing is getting kind of into that rhythm of thinking, this is like a puzzle. It's like a riddle. I need to find two numbers, that this, that. And it will get easier as you practice. The key is practicing. And I know that it is not something that is fun to do, but it is something that you will need to do. So we're going to do number 2a, 5x squared plus 5x equals 30. Here's a problem. I need that to say equals 0. So I'm going to move that 30 over to the other side by subtracting it. 5x squared plus 5x minus 30 equals 0. I see that there's a GCF across the whole problem, a 5, and a 30. I'm going to pull out a 5, which means I'm left with x squared plus x minus 6 equals 0. I'm going to factor this inner piece. And would you look at that, a equals 1. So when a equals 1, then I can just find those two numbers that will multiply but add to. So I'm going to multiply to negative 6 but add to 1. So my two numbers that do that, we're going to have negative 6 but positive 1. It's going to be the opposite of what we just did. So negative 6, positive 1, 3, and 2, where the 3 is positive and the 2 is negative. So x plus 3, x minus 2 as my factors. And then I'm going to use that zero product property, and I have x plus 3 equals 0. Subtract 3, and that gives me that x is negative 3. X minus 2 equals 0. Add 2, and that gives me that x is equal to positive 2. So my zeros are positive 2 and negative 3. And then this one here where it says 2 is the same problem as 2a, so don't worry about that one. So this page looks absolutely crazy, but I want you to know that that is good. That means you're doing the math, you're getting practice in. So your page should look like mine when you're finished with the homework on page 7. So this will be due, it is homework. Make sure that you're getting it completed. I will post the answers to the evens. Well, y'all do evens. evens, and answers to odds will be posted. Evens will be taken for a grade. So if you are absolutely confident, wow, I am so good at factoring, you can just do the evens. If you want to do the odds as well and then check your answers, then the answers will be posted to the odd questions. So that is it for today. Make sure you get your homework in, and thank you for watching.